Tan graph. We have already sketched the sine and cosine graphs. In this section, we are going to sketch a tangent graph. The next example is interactive, so we want you to participate and pay special attention. Take out your Casio FX82 scientific calculator and let's have a look at this example. In this example, we want to sketch the graph of y is equal to tan x. Let us compile a table of values. Look at our table. We chose the x values that differs with 90 degrees. We start with 0 degrees and we ended with 360 degrees.
So what do we do next?
Let us write down the equation of our graph, which is y is equal to tan x. Look at the table. Look at 0 degrees, which is here. Let us put 0 degrees in the place of x. So far we have y is equal to tan 0 degrees. Use a calculator. Find the value of tan 0 degrees. What value do you get?
I get 0 as my answer.
Okay, Digit. You get 0 as your answer. This means y is equal to 0. Let us write 0 in the second column, just under the 0 degrees. Look at the table. 0 degrees is here. Y is equal to 0 is here. Let us write our equation again. Y is equal to tan x. In the place of x, let us put 90 degrees. So far we have y is equal to tan 90 degrees. Use a calculator. Use a calculator to find the value of tan 90 degrees. What does your calculator say?
My calculator says math error. Did I press something wrong?
When x is equal to 90 degrees, tan 90 degrees will be undefined. This means we have a dotted line at x is equal to 90 degrees. On your table, just under 90 degrees, write undefined. Look at the table. Let us quickly put 180 degrees and 360 degrees in the place of x in our equation. And our equation is y is equal to tan x. We will get 0 for both of them. Let's write 0 under 180 degrees and let us write 0 for 360 degrees. Look at the table. If you look at the graph, you will notice that the graph of y is equal to tan x is also undefined at x is equal to 270 degrees. We have another asymptote at 270 degrees. So far, we have an asymptote at x is equal to 90 degrees, which is here. And another asymptote at x is equal to 270 degrees, which is here. Look at the dotted lines on the graph. Look at the table again. Look at x is equal to 0 degrees. X is equal to 180 degrees. And x is equal to 360 degrees. At these x values, y is equal to 0. This means they are x-intercepts. On our graph, we are going to put a dot at 0 degrees, another dot at 180 degrees, and another dot at 360 degrees. Look at the dots. Look at the horizontal line. X is equal to 0 degrees is here. X is equal to 180 degrees is here. And x is equal to 360 degrees is here. Draw curves. The first curve is from 0 degrees going up but not touching the asymptote at 90 degrees. Look at the graph. Let us now draw a curve starting at 360 degrees, going down towards 270 degrees, but not touching the asymptote at 270 degrees. Look at the graph. Finally, let us draw a line starting from 180 degrees, going up or increasing and approaching 270 degrees. The same line will also start at 180 degrees and decrease or go down and approach 90 degrees. Note that the curved line will not touch any of the asymptotes. Your completed tan graph should look like this. Look at the graph. You will notice that the graph doesn't have maximum and minimum values. Look at the table again. Also, look at the completed graph of tan x. We are showing you the completed graph and the completed table at the same time. Look at the table. Look at the second row. You will notice that the tan graph does not have any maximum or minimum values. This means it does not have any amplitude. We will explain amplitude in the next section. Let's have a look at the next example. In this example, we are given the graph of y is equal to tan x. Let us go to the first question. Let us use the graph to find the value or values of x for which tan x is equal to 0. Look at the graph. Tan x is equal to 0 means we must write down the values of x where the graph of tan x cuts the x-axis. The graph cuts the x-axis at 0 degrees, which is here. The graph also cuts at 180 degrees, which is here. And at 360 degrees, which is here. So, our x-intercepts are x is equal to 0 degrees, or x is equal to 180 degrees, or x is equal to 360 degrees. Let us now find the values of x for which tan x is greater than 0.
In simple terms, what does that mean?
Tan x is greater than 0 means we should find the interval on the graph where the graph is positive, which means greater than 0. Look at the graph. From 0 degrees to 90 degrees, the graph is positive. From 180 degrees, which is here, to 270 degrees, which is here, the graph is positive. So, our solution will be written like this. Look at the first inequality. The first inequality means x is between 0 degrees and 90 degrees. Notice that 0 degrees, which is the smallest number, is written on the left, and 90 degrees, which is the largest number, is written on the right. Look at the second inequality. The second inequality means x is between 180 degrees and 270 degrees. Our solution can be written like this. Let's have a look at the third part of the question. Tan x is less than 0. Tan x is less than 0 means we should find the interval where the graph of tan x is negative. Less than 0 means negative. Look at the graph. Look at 90 degrees, which is here, and 180 degrees, which is here. The graph is negative between 90 degrees and 180 degrees. We write our solution like this. Look at 270 degrees, which is here, and look at 360 degrees, which is here. the graph is negative between 270 degrees and 360 degrees. We write our solution like this. Let us have a look at another example. In this example, we want to draw the graph of y is equal to tan x plus 2. And we are given the interval which is from 0 degrees to 360 degrees. We already know how to sketch the graph of y is equal to tan x. To sketch the graph of y is equal to tan x plus 2, we simply have to move the graph upwards by 2 units. Look at the graph of y is equal to tan x. Look at this point, which is 0 degrees and 0. The x value is going to remain the same, and the y value, which is 0, will be added with a 2.
So the y value will become 0 plus 2, which is 2.
Yes, Digit. The y value will be 2, which means 0 degrees and 2 is a point that lies on the graph of y is equal to tan x plus 2. Let's quickly find the point 0 degrees is 2 on the given graph of y is equal to tan x. Look on the graph. The point 0 degrees and 2 is a point on the y-axis. This is true because x is 0 on the y-axis. 0 degrees and 2 is here. Let us now draw a curve from 0 degrees and 2, approaching the asymptote at 90 degrees, but not touching the asymptote. Our line will look like this. Look at the points 180 degrees and 0 and 360 degrees and 0. If we add 2 on the y-coordinate, they will become 180 degrees and 2 and 360 degrees and 2, respectively. Let's quickly plot these points. Look at the graph. 180 degrees and 2 is here. 360 degrees and 2 is here. Our asymptotes are still at 90 degrees and 270 degrees. Asymptotes are the dotted lines. Let us quickly draw a line that passes through point 180 degrees and 2. Our line must not touch the asymptote at 90 degrees, and our line must not touch the asymptote at 270 degrees. Our line will look like this. Let us draw another line that passes through point 360 degrees and 2, going down and approaching the asymptote at 270 degrees. Our line should look like this.
Phoenix. Where does this graph cut the x-axis?
Shoo! That's a very hard question. Look at the equation. Y is equal to tan x plus 2. Let us quickly rearrange our equation. Y is equal to tan x plus 2 can be written as tan x plus 2 is equal to y. Because you want the x-intercept, let us make y to be 0. So far we have tan x plus 2 is equal to 0. Look at this 2. This 2 will become negative 2 if we take it to the right-hand side. So far we have tan x is equal to negative 2. Next, let us ask ourselves a question. Where is tan x negative? We saw in the previous example that tan x was negative in the interval 90 degrees to 180 degrees, and the interval 270 degrees and 360 degrees. Look at this diagram. tan is negative in the second quadrant. And the second quadrant is between 90 degrees and 180 degrees. Tan is also negative between 270 degrees and 360 degrees. In the second quadrant, our angle will be less than 180 degrees. So we say x is equal to 180 degrees, subtract reference angle, which is RA. RA stands for reference angle. And we will have a closer look at it in topic 3. For now, just know that RA helps us to find our angles. In the fourth quadrant, we know our angle will be less than 360 degrees. We say x is equal to 360 degrees, subtract RA. Look at the picture. Take your calculator, press shift, then press tan, then press 2, then press equal sign. Your answer should be 63,435, correct to 3 decimal places. Look at the display on your calculator. This value, 63,435, we write it in the place of RA, which stands for reference angle or key angle. Look at the table. Look on the left side of the table. On the left side of the table, we have second quadrant. We have x is equal to 180 degrees minus reference angle. Our reference angle is equal to 63,435 degrees. If we subtract 63,435 degrees from 180 degrees, we will have x is equal to 116,565 degrees. And that's our value of x in the second quadrant. Let's have a look at the fourth quadrant. On the fourth quadrant, which is on the right, we have 360 degrees, subtract reference angle. Our reference angle was found to be 63,435 degrees. If we subtract 63,435 degrees from 360 degrees, we will have 296,565. And that's the answer in the fourth quadrant. Look at the picture. So we can say the graph of y is equal to tan x plus 2 will cut the x-axis at 116,565 degrees, which is here, and also at 296,565 degrees, which is here. Look at the picture. Try the following activity.
The first one has been done for you.